Extremely important question with innovative solution. In this video, you are going to understand how we can solve the question even when we have complex roots for the given equation. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos, posting excellent comments and suggestions. The question comes from one of our students who is taking SAT, where time is the major issue. Questions may not be very difficult, except for the last four or five, but if you have enough time, you can always solve them. So here is a very beautiful question with amazing strategy to learn. Let's see the problem and solve it. The question here is find the value of p if the sum of roots of f of x is 5 by 2. F of x is given to us as 2x plus p times 3x squared minus 27 times 2x squared minus 8x plus 20. So the sum of roots is something which is given to us. Let us find the roots of this equation. So, the roots will be what? Roots will be that each factor should be equated to 0. That is to say, we'll do 2x plus p should be equal to 0. That gives us x equals to minus p by 2. Right? So we got the first root. Now the second term here is 3x squared minus 27 equate to 0. So we have 3x squared equals to 27. X square equals to 27 divided by 3, which is 9. Let me take it here. So x is equal to plus minus square root of 9, or x is equal to plus minus 3. You see, we got conjugate roots, right? Plus and minus 3. When you add them, they will be 0. So you do get conjugate roots, and when you add them, you get it 0. Perfect. Now the third term here, which is 2x squared, let's equate that to 0. We have 2x squared minus 8x plus 20 equals to 0. We can take 2 common. We have x squared minus 4x plus 10 equals to 0. Now, if you try to factor, it will be very difficult for you to factor, right? So we may use the quadratic formula to find the roots. So x equals to minus b, which is 4, plus minus square root of 4, square of 4 is 16, minus 4ac. So 4 times 10 is 40 over 2 times a, which is 2. So these are the roots. So what you really notice is that the other two roots which we have are basically x equals to, I can write this as 2 plus minus square root of a negative number, right? That means a complex root, right? Some of you have not yet done complex roots, right? So if I do, what do I get? I get 24, right? Minus 24 divided by 2. So I already did 4 by 2, which is 2, plus minus minus 24 over 2, right? Now we need to add all the roots, right? So this is plus and minus, two roots, conjugate roots. So concept here is that these are conjugate roots. Means if you add them, they will cancel away. And what we are given is that the sum of roots of this function is 5 by 2. So 5 by 2 is basically equal to the roots which are minus p by 2, plus 3, and minus 3, plus 2, and plus square root of minus 24 by 2, and also plus 2 minus square root of minus 24 by 2. So even if it is complex, it doesn't really matter because it cancels. You see that. So we are left with 5 by 2 equals to minus p by 2 plus 4. Multiplying by 2, we get 5 equals to minus p plus 8, right? And bringing p here, we have 8 minus 5, which is equal to 3. So we get the value of p as 3, right? So we have our solution p equals to 3. So see, we have found the answer itself. Perfect. Now, I'd like to share with you a strategy. The strategy here is, since you realize that the roots are conjugate, you need not even do this calculation, right? So what I'm saying here is avoid. And if you avoid this, what should you do? Well, when we are adding roots, just use minus b by 2a. So each root is minus b by 2a, two of them, right? So if you do minus b by 2a, you will get 2 plus 2, 4. And you could actually get to this result faster. So for those of you who have picked up this strategy, it will matter a lot. Else, do as I have shown here. Perfect. So I hope you have understood the strategy. Feel free to write your comments, share your views, and if you really want to learn from me directly, send an email to globalmathinstitute@gmail.com. Thanks for your time and all the best.